Greetings and welcome to my COSPAR summary. I'm going to be talking about the results from the integrated science investigation of the sun on Parker Solar Probe. We're exploring the energetic particle environment very close to the sun, seeing energetic particles just as they're first being accelerated and learning the basic acceleration processes operational within our solar wind, our heliosphere, and our solar system. I'd like to acknowledge my co-authors, as well as those who have made the Parker Solar Probe Plus mission possible. The ISOIS investigation of the sun, this is the energetic particle suite, and we have data releases through August 13th of 2020. Encourage people to use the tools that are available through the Princeton site shown here, as well as the SPDF. Use the data, let us know about your studies, and we look forward to collaboration. On the bottom left is the epi-low instrument, right epi-high instrument, the lower and high energy particles sitting on the ram side of the spacecraft near the backside, blasting in close to the sun to distances where no spacecraft has gone before. So this is truly a mission of discovery. So far, we have made observations to the first 6 orbits, Parker Solar Probe orbits. We see SEPs that are all circled here, very small solar energetic particle events in addition to co-rotating interaction regions and stream interaction regions. Orbit 1, Orbit 2, Orbit 3, on the inside of these tracks is the epi-low count rate data, on the outside, epi-high count rate data. We see solar energetic particle events of various types. Interestingly, you see the fewest events in orbit 3, and then the event rates start to pick up. If you take a look at the sunspot number, you will see orbit 1 is during a period of declining solar activity. Orbit 3 actually is right at the minimum of solar activity, and then we see increases of solar activity beyond that point. So in fact, the period at which we've studied observations so far in 2018, 2019, and 2020 has been the deepest part of the deepest solar minimum of essentially the space age. So that's the reason that we're seeing such small solar energetic particle events. And at this point, going forward, we will be seeing larger and larger energetic particle events. It's actually nice to start the mission with things that you can piece together and really understand well. This is an example of one of the orbit 2 events that we saw. This was one of the largest events that we saw, even though it's a very, very small event. And actually, during the ICME arrival, this was a series of different coronal mass ejections, and then you finally see an ICME arrival near the 20th of April or 21st of April in 2019. You see basically seed populations that get compressed, and those seed populations include helium-3 from flares. So we're actually seeing the process of seed populations coming out from flares and then being swept up and compressed in front of the coronal mass ejection. This is another example of the types of things that I report in this talk. This were a series of SEP events that happened very close to perihelion. This was in orbit 2. The first of these events, a dispersion event that you see at very low energies. The second event, also a dispersive event, but now extending to high energies. This is actually from the same active region. See coronal structure dynamics, erupting loops, type 3 radio bursts that are on top of these. And the variability between these two events tells you that these eruptions that are coming from the same active region have very different behavior from point to point. It tells you how variable the acceleration processes are close to the sun. This event was a Z-rich event, and it was also indicates a possible lower beta magnetic structure between the two events. Another example, this was in orbit 5, a series of 6 eruptions, homologous eruptions from the same active region. In this case, the Cohen et al. Study in 2020 studied the helium to hydrogen ratio, variability by more than 2 orders of magnitude. So incredible variability from the same active region. Again, giving you a sense of just how variable these events are. So the bottom line is we see a series of different solar energetic particle events, very small events because we're close to solar minimum. And we see lots of different acceleration processes that manifest. Flare populations, compressed within CMEs, compressional acceleration, acceleration from shocks, and evidence of acceleration from magnetic reconnection. The bottom line is that what we're seeing is not one type of acceleration process, it's really all the above. And I think the challenge in understanding this data is being able to understand the complexity of events that the sun throws at you, because we really are seeing all the different types of variability close to the sun that now we can piece apart because we are so close to where these events are first formed. Thank you very much.